Okay, so hello guys, we're back today and we're going over the AP Statistics 2023 FRQ. So I took statistics also. I took statistics on May 8th. Wait, was it May 8th? I think it was May. No, it was May 4th. May 4th, 12 p.m. So, okay, here's the FRQ packet. Now you can see my cursor, so I apologize for the chemistry video where the cursor actually caused more significance. You can actually see it and I didn't really feel like re-recording the video. So hopefully you can see the cursor now. Apologize for the chemistry one again, but hopefully you were able to follow through. Okay, statistics. What do you guys think of it? Let me know below. Here, okay, and let's quickly go over it. Bunch of formulas. Okay. First question. As part of the study on the chemistry of Alaskan streams, researchers took water samples from many streams with temperatures colder than 8 Celsius and from many streams with temperatures warmer than 8 Celsius. For each sample, the researchers measured the dissolved oxygen concentration in milligrams per liter, mg per liter. Researcher constructed the histogram shown for the dissolved oxygen concentration in streams from the sample with water temperatures colder. So we're doing colder than 8 Celsius first. Based on the histogram, describe the distribution of dissolved oxygen concentration in streams with water temperatures colder than 8 Celsius. Okay, so this is going to be SOX. We're going to be describing a distribution. We're going to be shape, outlier, center, and spread. Okay, shape, obviously, we're describing the distribution. Shape, we're seeing it's skewed left. Shape, okay, what else? Are there any gaps? Yes, there's a gap between 3 and 4 is what you could say. And peaks would be between 11 and 12. Outliers, in terms of outliers, you could say that 2 to 3 is a potential interval for an outlier over there, one of those. Center, you could say the mode is between 11 to 12. That's a pretty easy one. I think I got the mode wrong or the center because I messed up and I miscounted them, but that's okay. Center, okay, and then spreads. For spread, you could easily do range. You could say that the range is, I don't know, 14 minus 2, what is it, 12? Because that's where the maximum is and that's where the minimum is. So you can just say it's 12, and you should get the credit for that. Describing distributions, pretty simple. Moving on. Researchers computed the in summary statistics shown in table for the dissolved oxygen concentration in streams from the sample with water temperatures warmer than 8 Celsius. Use the summary statistics to construct a box plot. Okay, box plot construction warmer than 8 Celsius. Easy. We're given the minimum, 2.1, which would be about here. So we would draw the long whisker right here. And then Q1 would be at 4.39. We'll go from here to 4.39. It would be like about right here. A smaller one, which is where the box begins. Median is at 5.43. 5.43 is about right here. So this would be the middle, or okay, so it would be like something among these lines. This would be, oh, sorry, yep, something like this. There would be a box right here. Q3 is at 6.12. So from the median, we would go further and we would draw the other part of the box. And then maximum is 13.45. We close the box off and go all the way to 13.45 and then draw the long whisker here. It should look something like that. I didn't really draw it because Chrome doesn't really let me draw. And yeah, anyway, but that's what you should have a basic idea of it. If you're taking statistics, it's a box plot. You're given the information there. You don't really need the mean or standard deviation. Okay, I'm not gonna read all this, but okay. Using characteristics of the distribution of dissolved oxygen concentration for temperatures colder than 8 Celsius and characteristics of the other distribution. What is the question? Which streams are generally healthier for wildlife? That streams with higher dissolved oxygen concentration. So based on this box plot, we can see that this one's actually skewed right and that the colder one is actually skewed left. So because more of it is concentrated on the higher dissolved oxygen concentration for the colder one, we just argue that the colder one is there because, you know, it's skewed left, not skewed right like the warmer one. It's not that hard. Pretty simple. All right, a little bit of experiment. If you read all this, experimental units would be 60 new homes that need driveways. And then the treatments would be either concrete that contains fiber or concrete that does not contain fiber, which is stated in the problem. That's the treatments. Experimental units, 60 new homes that need driveways. The response variable is on a scale of 0 to 10 of the severity of cracks, and then you could just say 0 representing not cracked at all and 10 representing severely cracked. Just write that out right there. Describe an appropriate method the developer could use to randomly assign concrete that contains fibers and concrete that does not contain fibers to the 60 driveways. Okay, well, you could begin with label. You would label the 60 new homes from 1 to 60. And then you'd use a random number, and then for randomizing, you just use a random number generator to generate 30 unique numbers that are non-repeating. You would write all of this down there, of course, and then you would assign those first 30 that are picked, concrete that contains fibers, let's say, and then you would assign the rest the concrete that does not contain fibers, and then you'd choose the corresponding homes with those numbers, and I guess distribute the condition of the concrete. Alright, suppose the developer finds there's a statistically significant reduction in the mean severity of cracks in driveways using the concrete that contains fibers compared to the driveways using concrete that does not contain fibers. What is the benefit of randomly assigning the driveways to either the concrete that contains fibers or concrete that... Because random assignment allows us to assign a cause and effect relationship. Yes. So by randomly assigning, we can establish a cause and effect relationship between concrete and whether concrete with fibers or concrete without fibers actually has, a difference. If it was randomly assigned, we'd be able to generalize these results outside of the 60 homes which the problem stated. But because hold on. It says randomized experiment with 60 new homes. It doesn't really say they were randomly assigned or randomly chosen. It was randomly assigned, which allows us to do cause and effect relationship, but it doesn't say it was randomly selected. So, but that's not what the question's asking. The question's asking cause and effect. Mostly, it's looking for cause and effect answer due to random assignment. That's all you need to put. Okay, we don't talk about this problem. Bath feces. What do we have here? We have probability distribution. We have these numbers. Calculate the proportion of bath feces that contain $1. Easy. What we do, 1 minus these values, and we get the probability of cash price of $1. Right here, probability. Calculate the proportion of bath feces that contain at least $10. Again, not that hard. At least 10. We just add all of these up, and we get our answer. Based on probability distribution of X, calculate the probability that a randomly selected bath feces contains 100, given that it contains at least 10. What we do is this is a given problem. So what we do, we could go up to the formula sheet technically. Where is it? Right here. The given formula. A given B equals A and B over B. Okay. And now if we go back here, given that it contains at least 10. So, probability of 100 and at least 10 over probability of at least 10. But the thing is, if it's 100 and at least 10, 100 is already at least 10. So we just take this number and we put it over whatever the answer to this one is, which is these added, and you'd get your probability for this one. Based on the probability distribution of X, calculate and interpret the expected value of the distribution of the cash price in the bath feces. Show your work. Okay. Calculate and interpret the expected value of the distribution of bath feces. It's not that hard. We go up to expected value formula. It's right here. Where is it? Yeah, right here. You basically add all of them up, right? So what you would do is you multiply whatever this probability is, which you should have gotten right here, times 1, plus this times 5, plus this times this, plus this times this, plus this times this, plus this times this. Pretty simple. You get your answer, and you also have to interpret it, which is important. And you would just say that if we were to select many bath feces, the expected amount of cash price to get from each on average would be this. It would be a positive value, definitely, but it would be a very small positive value. We don't talk about the euro question, but I got this one wrong because I mistyped into my calculator. Someone might come and make fun of me soon, but anyway, yeah. So what honestly, all you need to do for this, you take the value you got from C and you multiply it by 0.89, because for each dollar it's 0.89 euros. So you use the expected value and convert it to euros, and you get your distribution of the cash price in bad feces to euros. Not that hard. I messed up because I first did that, but then I went through the longer method and I got different answers, and so I put the wrong answer down. But my bad. Question 4. A lot of wordy stuff. I'm not reading all that, but at the end of week 1 and week 3, each patient was given 0 to 10. We got our we got our information here. But the thing that's important is that they give us difference, placebo minus omega-3. This sort of already tells us that we might be having to use mu-diff or true mean difference instead of true difference means. They're two different things, and you, for this one, you want to go with true mean difference. Why? Because the difference in placebo minus omega-3, they give you that, they give you the mean, they give you the standard deviation, which you're going to be able to do for this question, and do a state plan do conclude with a significance level of 0.05. I'm not doing all that, but hopefully you already know how to do a significance or state plan do conclude for tests. It's a test, right? Inference procedure. Yeah, significance level, statistical evidence. Yeah, this is a test. Okay. Okay, a little bit of duffs. Wildlife, what is it? Species of deer in California. Weight of tool elk is difficult to measure in the wild. Chest circumference is working. Okay. Alright, describe the relationship between chest circumference and weight of the male tool elk in context. Alright, so what you would say is the relationship or the association between chest circumference and weight of male tool elk in captured 30 male tool elk in California, I guess. Or is it California? Yeah, you would say captured 30 male tool elk is positive, because it's positive, linear, it's relatively linear, and moderately strong, because you can see how it follows a sort of a linear pattern. You know, the dots are compacted around an imaginary LSRL line. So yeah, you would say association between chest circumference and weight of male tool elk in context is positive, linear, and moderately strong. You could say, and I did say that there's a cluster between 135 centimeters to like 155 centimeters. I don't think you needed to say that. You could, to ensure you get the point. Maybe I was wrong, but it literally looks like there's a cluster of points up there. Correct me if I'm wrong. Moving on, in question 5, we got B. The weight of one male tool elk, which is a circumference of 145.9 centimeters, is 204.3 kilograms. Calculate the predicted weight for this male tool elk. Easy. What you do, chest circumference, we're given, plug this value in for here, use your calculator, and get your predicted weight. There. That's all you need to do. Simple math. Plug in, check. Calculate the residual for this male tool elk. Okay. Residual, okay, we use the RAP acronym. Residual equals actual minus predicted. Actual, we're given the actual. We subtract from whatever we get here. And we get a positive value, I believe it's like 8 something. And then residuals do have units, so you would put whatever the number is, kilograms. That would be your residual, whether it's positive or negative. Interpret the slope of the least squares regression line in context. Okay. You would say, what would you say? Okay, we have the slope is right here. So for each 1 centimeter increase in chest circumference, the predicted weight of male tool elk would increase by 3.7455 using LSRL, where X equals chest circumference. Something along those lines. Okay, now we're getting into a little bit of chapter 12 material here, because we're testing for slope. A bunch of words. I ain't reading all that. Test statistic was calculated to be 3.408. Assume all conditions for inference are met. That's good, because conditions are way too long. Liner is ridiculously long. Determine the p-value of that test. Okay. We're given the test statistic. So it's a two-sided one. So what you would do is you do minimum 3.408, maximum 999,999. Then if we go up, Okay, let's see. Mean is whatever the slope is. So 4.5. And then for this one, we'll just... Are we given standard deviation? I don't know. If we don't, we'll just use the formula and plug that in our calculator. I'm not doing all that, but hopefully you already know how to do that. That's question 6. Okay, there we go. Determine p-value. You get a number. You would multiply by 2 because it's two-sided, and then, yeah. Chest circumference is 4.5, so you have your mean. Yeah. Oh, wait, I'm tripping. Okay. Oh, we're doing with slope. We don't need really standard deviation. What we would do is we would subtract 2 from 30. I forgot that. Yes, and you get your DF of 28. That's what you would plug in, not 4.5. You would say minimum that, maximum that, minimum that, maximum 99999, DF of 28, and then it would spit out a value at you, and then you would multiply by 2 because it's two-sided, and that's your p-value. This is not a state plan do conclude, even if you think it is. It's only the conclude part of the state plan do conclude, and what conclusion should the wildlife biologist make regarding the slope of the population regression line from L to look at significance level of that? If the p-value is low, we reject the whole or the null hypothesis, and I believe it does end up being low. I'm not tapping in my calculator right now, but yes. And if it's low, we reject the whole, and we have convincing evidence that the slope of the population regression line from male to elk is not 4.5 kilograms per centimeter in LSRL, where x equals chest circumference or something along those lines. Should get you the point. It's only a conclude part. There's no double jeopardy, so even if you get the wrong p-value and if you interpret it correctly, you should get the point. For this one, not this one, because obviously you got it wrong. Okay, question 6, pretty long one. It wasn't that hard. I actually thought it was pretty easy. I just messed up on some parts, but I could have easily gotten a better grade on it. It's about jewelry. Okay, jewelry company use machine coding, gold machine. Okay, mean 300, standard deviation 5. It's a bunch of normal CDF stuff. Random selection, assuming the machine is working properly, calculate probability. Gold applied is between that, easy. Minimum 296, maximum 304, mean that number, standard deviation that number, and you got your answer. Whatever it spits out the calculator. Calculate the probability that sample mean amount of gold applied to a random sample of n equals 2 necklaces will be greater than 303 milligrams. Again, normal CDF. What you would do, okay. Being applied. Okay, so mean remains the same. Standard deviation is still 5 milligrams. For this sampling distribution, however, because we're dealing with sample size 2, we're still doing normal CDF. Minimum 303, maximum 999,999. Mean of this, but standard deviation would be 5 divided by square root of 2, I think. Correct me if I'm wrong. Where is it? We're doing with means. Yeah, right here. Because we're doing with sampling distribution, it would be the standard deviation divided by square root of 2. And it'll give you some value that I don't have on top of my head right now. Necklace, okay, let's do this one. I'm gonna go to applied. Took a random sample of n equals 2 necklaces that resulted in sample mean amount of gold applied of 3. Would that result indicate that the population mean amount of gold being applied by the machine is different from 300 milligrams? Okay, this one was hard. I don't remember what I put. Okay. Suppose Cleo took a random sample of n equals 2 necklaces that resulted in the sample mean amount of gold applied. Oh, right. You just do the conclude part again. You'd use this statistic, and if the probability is very small, then you would say that the results do indicate that the population mean amount of gold being applied by the machine is different from 300, because getting that high is very unlikely. However, if the probability is very high, then, well, we can't really say much. then we just have to accept that it's 300. I believe the probability ends up to be like 0.08 or something. So you would just you'd have zero indication that the population mean amount of goad being applied by the machine is different from 300 milligrams. Okay, now this was where question 6 becomes question 6. A bunch of info on here. We have standard deviation of 5, standard deviation of 8 graph, and standard deviation of 12, and we have sample ranges. We can see that it's becoming more skewed. No, hold on. This is the strongest skewed, right? This is less skewed, right? Okay. Sampling distribution of the sample range for random sizes of n2 from a normal distribution with a standard deviation as shown in graph 1. Okay. Easy. Sucks, but you use this graph to describe it. You would say skewed right, no gaps, peak at 0, outliers, not really, center, you could say mode is 0 or something. Spread, you just say like, if you zoom in, that's like 21, 20, 21, 22, like 22 minus 0, that's like what, range of 22? Yeah. Simple sucks. Describe how the sampling distribution of sample range from samples of size n equals 2 changes the value of the population standard deviation as the value of the population standard deviation increases. Okay. So how does the sample, how like, as this increases, what happens to it? I think I said it becomes less skewed right and the range becomes greater, so the spread becomes greater and it's less skewed right. Something along those lines should get you the point, because that's evident. This is very strong skewed right. This mildly, this even less skewed right. So still skewed right, don't get me wrong, but not as much. Okay, last part, last 2 questions. It's at the end. Oh, it's these. You don't need these. Okay. Recall that Clio needs to consider both the mean and standard deviation of the amount of the goad applied. Okay. Recall the machine is working properly if the amount of goad applied to necklaces has a mean of 300, standard deviation of 5. Consider Clio's range of 10 milligrams from the sample size of 2. If machine is working properly with a standard deviation of 5 milligrams, is the sample range of 10 milligrams unusual? Okay, what you would do for this, standard deviation of 5, standard deviation of 5, 10 milligrams. We'll go up here, 5, 10 milligrams. We start right here. This like 0.3. If we add from here all the way down, we'd get like what? Like, we get like more than 0.05. I got this one wrong because all I did was look at 0.3, which is like 0.35 or something, instead of counting all the way down. But you would say it's too big, so we can reject it. I rejected it, so I said the sample range is unusual when it really isn't. So you would say it isn't because it adds up to more than 0.05, which is the usual significance level they go with. So it's just a conclude part, of a state plan do conclude procedure. Do Clio's sample mean of 303 milligrams and range of 10 milligrams indicate the machine is not working properly? Explain your answer. For this one, what you would do, you would go all the way back here, you take this value, and you take this value, and you multiply them together, and then you get your number, and then if it's lower than 0.05, you reject the whole, and you say that, what do you say? Well, yeah, you say that machine is not working properly because chances of getting those two is very low. But if the probability is high, then you can really deny it, that it's not working properly, and you have to agree with the fact that it's working properly. Ooh, that was tiring. Okay, I think I got this one right, got this one wrong, and I got the Euro question wrong. This one. So maybe some other questions wrong, but I think I got everything else right, to be honest. Yeah, that's it. That's statistics 1. Okay, so by now there should be 2 other videos live on our channel. We got I went over the AP World History and I went over the AP Chem. Now I went over AP Stat. I'm gonna have a short going out on AP Seminar, and probably my other co-runner of the channel will cover AP Seminar personally, as well as AP CSP. So look forward to that. I'm gonna end the video now. Hopefully, I think you were able to see my cursor, so following along shouldn't have been a problem. I did not do any solutions. Again, this channel, like these videos, the purpose of them was to simply go over them briefly, to go over the questions briefly, rather than go into in-depth analysis of the answers. So I'm pretty sure there's videos out there and TikToks and whatnot, other social media platforms utilizing videos which go over answers more in depth. So I hope you enjoyed the video though. Let me know if you have any questions, any notes, anything that you want to discuss in the comments. I'll be sure to look over it, hopefully answer some of them. And so yeah, I will be sharing my scores on these exams. I took 4 exams. I will not be discussing AP Seminar for certain purposes I will discuss later. I will share my scores once they go live. So look forward to that. Maybe there'll be other videos going out and posts once we unlock them. So thank you for watching, and I will see y'all later. Peace.